Hello, hello. Let's take a look at more examples that we can solve today by practicing multiplication of decimal by decimal. We are on page 47 and we're going to solve number 10. Notice in number 10 we have two tasks. We first have to estimate and then the second job we have to multiply. So we have a two-step calculation. Let's learn to estimate multiplication of decimals. I'm only going to do this second box, right? I'm only going to do the second box, BDFH, JL, and I'll let you do the first box on your own. So let's try to estimate. I'm going to pick up maybe purple marker. 4 times 0.7. Well, we do know that 0.7 is very close to a half, right? So it's like 4 times 0.5, and a half of 4 is about 2. Next, 3.7 times 3.9 times 0, so let's just write here, about 2. Now let's just write this answer. 3.9 times 0.7. We can think that 0.7 is close to 1 whole, so our answer should be around 3, or we can think of it as a half, right? It's just eyeballing it. So let's just say the answer should be 3. By no means your answer should be 30 or 300. That's what we're trying to get to, just to kind of see, are we in the teens? Are we in the hundreds and the thousands? Now, estimating F, 9.42 times 0.3. Well, 0.3 is 1/3, right? 0.3 is about 1/3. So 1/3 of 9, we should have about 3 as our final product. Now, 5 times 100, 700s. Ooh, that's going to be a much smaller number. So I would say 5 divided by 100, it's going to be around 0, very close to 0, and so on. Now, what I'm going to do, let's pick up new marker, new color, and let's compute exactly using mental math. I always encourage my students to use mental math whenever possible because sometimes it's just faster. Let's go using our knowledge of how to multiply by a decimal. Step 1, ignore the decimal places. 4 times 7 is 28. Let's write down the digits. We have 28, but obviously the answer should be much smaller. We have 1 decimal place, so we're going to count 1 decimal place in our product, and the answer is 2.8, which is super close to our estimation. 3.9 times 0.7. Well, we can just multiply 3.9 times 0.7. Oh, this is 9, and this is 7. It's like 39 times 7, and the digits are 2, 7, and 3. However, we do have 2 decimal places, right? And therefore, we need to count 2 decimal places in our product. And the final answer is, the final product is 2.73, which is close to our estimate of 3. Now, F, 9.42 times 0.3. Let's go. 9.42 times 0.3. Notice how I stack it up. Step 1, let's first compute without worrying about the decimal places, just to get our digits correct. And we have 6, we have 2, correct, and then we have 2 and 8. However, obviously our answer cannot be 2,826. Let's compute the decimal places. We have 1, 2, and total 3. So 1, 2, 3. And our final product is 2 and 826 thousandths, which is very close to our original estimate of 3. Now, H, I'm computing H, and that's pure mental math. 5 times 7 should be 35. I got my digits, but I need to count my decimal places. There are 2 decimal places in one of the factors. Therefore, I'm counting 2 decimal places in my final product, and the answer is 35 hundredths. Now, J, let's just try to compute mental math. 39 times 4. Step 1, ignore the decimal places. 39 times 4, well, 40 times 4 is 160. 39 times 4 is 156. So I got my digits right. Now let's figure out the decimal points. The decimal point, we have 1 decimal place, 2, 3. Therefore, the final product will have 3 decimal places, and the answer is 0.156 or 156 thousandths. And the final example, L, we can also do mental math. 12.7 times 300ths. Let's just do something like 127 times 3. mentally. You can do it mentally. You can do it stacked. Let's do it stacked. Maybe that's easier. So we have 1, we carry 2, we have 8, 381. Obviously, the answer cannot be 381. We just got the digits correctly, which is the first step. And now finally, let's compute the total number of decimal places. We have 1, 2, 3 in all the factors. Therefore, we will have 1, 2, 3 in the final product, and the answer is 0.381 thousandths. I hope this practice helps you how we can use mental math whenever possible, or our typical, standard stacked multiplication algorithm to multiply decimals by decimals. We have all mixed decimals over here in exercise 10. We saw how we can estimate it, and yeah, I hope you're becoming pros at this process.